Let me introduce my project here. Well, I don't know what's going on with the projector. This is a book I co-authored, ham radio, for the Arduino and the Pickaxe microchip, ARRL. I have 2 chapters in here. It's currently on sale at ARRL. It was printed just this March 1st. So I wrote the articles about 18 months ago, and it's taken darn close to a year because there was a death in the ARRL family. The editor was killed when his home burned down, and so that was a little bit of a delay. And so anyway, this is what my presentation is about tonight. The 2 articles I wrote had to do with a solar tracker. I've built a couple. Some of you had lunch with, where I've had lunch with you at Carl's Jr. last year. You probably remember my large solar tracker. Well, this one is written especially for the book. It's dirt simple, and everything is locally available, which so many projects you have to mail order special parts from Newark or DigiKey or somebody. Everything here is you can get locally. To show you how dirt simple it is, I didn't paint it or anything. It's ugly. It uses model airplane wheels, model airplane servo motor for a nice gearbox. The solar panel is just for demonstration purposes. It's one that you put on the dashboard of your car to keep your battery from dying. Like you have a 4th car sitting in the driveway, you only drive it on Sunday, you might have this on your dashboard to keep your battery from failing. So I used that, and it tracks the sun around through the electronics up here, and we'll get into more detail later. But I made this one just to be dirt cheap, simple to build. As a matter of fact, even the platform under here that's holding the panel, that's 2 pieces of cardboard glued together. So that's how cheap I tried to get it. And because of that, it took me forever to hunt down parts. This nice little bracket that fits here on top. Over at IKEA, they have those big tubs full of stuff, and sometimes the stuff is $1 each. Well, the stuff one day were a whole bunch of in-out boxes for your business desk, your office desk, the in-box and the out-box, made out of nice big sheets of black plastic. So I bought 3 or 4, and that's what this is. This is actually a piece of that in-out box. And then, then I measured this, and I cut a block of wood about the same size, and I used my heat gun, and I slowly warmed it up. This plastic's really cool to play with. But anyway, so that's how I made the little flange to clamp on. And then these are the standard green LEDs, and the little circuit boards inside. And it's dirt simple. And that's what a lot of this is about tonight, is how one little microprocessor chip can replace tens of components, especially as they're becoming rather expensive now. Potentiometers, resistors, capacitors, well, resistors are very cheap. But some of the things you may not have, so you have to drive across town. There's $10 worth of gas to drive over there, come back, you get a ding in your door. But with the microprocessor, you just program it, and as your ideas change, rather than warm up the soldering iron, warm up your Windows laptop and just reprogram the chip. The chips will program thousands of times. I'm probably up to 999 already, just for making break failures. So that's what the 2 are about. This is when Sydney, K6DMT, first started here. He was going to go to the Amazon. So we wanted to know when he was going to be on the air. So I made a very special beacon that only beacons 3 times for 10 minutes and stops. Well, you can't find any keyer that'll do that. So you simply turn it on and start sending these same batteries that went to the Amazon. So this has already gone to and back from the Amazon. And this keys is TS2000, or any other radio, Yaesu, doesn't matter. So inside are the batteries, microprocessor, and to show how simple it is, this was just an old earphone plug. Probably the most expensive thing in here is the battery pack. There's just 3 AAs. And then I tried to make it pretty. I put a little picture of the world in the middle there with the on-off switches. I thought that was cool. That's what really makes it work. And I'm kind of doing this while that is booting. One of the problems we have with microprocessors, you can do all these cool things. Maybe some of you are into some heavy math. And others, you want to do robotics, and you want to control wheels and gears and and whatnot, you know. So the hard part many times is turning the microprocessor intelligence into mechanical motion. Well, you've already seen the example of a gearbox up there. The radio control model airplanes. Is that the one I have here? I got to go over here. Let's see. That says 0 at the top. Let me just go over here. Hang on a second. So getting mechanical motion being the hard part, I went down to the model airplane store, and I got a servo motor for a model airplane, and I took it all apart because model airplane servo motors only turn about 170 degrees, and I needed something that turned 360 degrees. So I found out how to make them turn 360 degrees, and so it drives the wheel on the solar tracker. I'm just giving you a little preview here. And so as the sun rises over here in the morning, you know, it goes around, picks up the sun, and it tracks it all day long. It only looks at the sun once every 10 minutes because it's ridiculous to look at it all the time. Plus, you know, when you're demonstrating these things, what happens? People come up and try to make it move. It's the first thing that happens. It isn't going to move because it's only going to look at the sun once every 10 minutes. Now, when it moves and it goes like stuff. So current draw on a motor is very, very high at startup. The startup pulse, current surge is very high. So although I pulse this into position each time, you have to be careful with battery power. So on my very large solar tracker that I built, I had to run a 7 amp battery just to keep the voltage up steady. Although the Logic's 5 volts, the motor, one of the motors draws a couple amps when it starts. These draw a few hundred milliamps at best. And what you get for $12 is a fantastic ball bearing motor and gearbox. Then these rotate around, I guess I kind of forgot, somewhere in the range of 100 RPM. So a small wheel like this, you get a real good torque out. This is another way to transform your computer logic into mechanical energy. The RV servo motor, 360-degree modification, and it drives a screw. And this little block of plastic is threaded to the screw. So as the motor rotates, the screw, lead screw rotates, and this block moves slowly up and down. It'll break your fingers. It'll also push quite a few pounds of load. So you can use it to open maybe the trap door to your wife's orchid what do they call it, hot box? Yeah. So where they're growing their flowers, you can open and close the door according to the heat, or open the bathroom door for you. But this is just one example of how to make mechanical energy. Okay, so I'll get into it. So there's the cover to the book. Like I say, it's brand new. It's written by quite a few of us. And our editor is Lee Klotz up in the San Francisco Bay Area. And Lee is extremely well educated, has a tremendous amount of experience in microprocessors. I started a little bit before I really knew him, and I was invited by Lee to write a couple of chapters. In all, there were 9 authors with various backgrounds, 19 chapters of projects. Projects are all designed to be very low cost, as I've already demonstrated. You can build it in 1 or 2 weekends, because we know people get, everybody wants something to happen really fast. So we want to make it dirt cheap and easy. And these are introductory projects. None of these are finished. They do one thing, and you apply your imagination through the programming if you want to do more. For example, the platform for the solar tracker will swing all the way and follow the sun until the sun sets. Well, wouldn't it be nice if there was a little switch that told it to go back to the position for 8 a.m.? Or maybe a real-time clock that does that instead. It says, oh, it's 8 p.m., we're not going to see any more sunlight, so rotate 180 degrees and wait for the morning sun. And it'll go to sleep by itself. So there's a lot of little things like that that can be added on. The motor driver in the black box the LEDs can be pulled off and replaced with 5K pots. And so now you can manually turn the shaft to your antenna tuner mounted up there on the roof. So how cool is that? So one pot would go on the shaft, this feedback of position. The other pot you're turning with your hand. When the voltage drop on the two are equal, the shaft stops. Of course, there's another problem involved. You need a multi-turn pot, but that's what you get to figure out. So I can tell you how to, you can go in that direction, but I'll let you figure it out for yourself on how to get there. Or you use a tachometer. There's lots of things you can use. So that's the way we built these projects. The Morse code keyer, it's kind of finished. What you could do on the Morse code keyer is you could add temperature. So maybe Sydney's down in the Amazon. He's not here tonight, K6DMT. He's away on a trip. But anyway, he took that down to the Amazon and it transmitted every now and then. So it'd be kind of cool if maybe it transmitted the temperature, or maybe it had 3 or 4 memories that says, I'm having a great day. So you push a button and it transmits something like, I'm having a great day, A-OK. Or another button that says help. Just some ideas. You all remember the old Apple and the S100 8080 PCs? I built my first one in 74, 75. This is the way it looked when you bought a little kit. It just came with a whole package of little tiny parts. And sometimes, like a newbie might not know the difference between a resistor and a capacitor or a reductor. But anyway, that's a typical kit right there. I built it. And that's kind of replaced. This is actually a motor driver. And this little chip right here is the microprocessor. In this case, it's a PIC-X 18X. And this is the version of firmware, which you don't care about right now. So this guy has about 6, well, it has 8 outputs. And I think it had, if I remember right, of the 8, they can also be inputs for infrared, Sony remote control, analog digital converters, or just straight on-off logic. So you tell it at the beginning of your program, you tell each pin whether you want it to be. It's that easy. And then you use it that way. So you can use this as an LED dimmer, etc. And this is a little circuit board from Revolution Education. Just makes things easy. So this is used for one of my early solar trackers. So there's the inputs for the 2 LEDs, left, right, up, or down. And this is where it's programmed. So a lot of people say, well, how do I program the chip? I got to buy a separate $50 programmer circuit board. But in the PIC-X series, the programming's right on the board. You get a couple of resistors, and here's a stereo jack connector for receive and send serial data to the COM port on your PC or Mac. Pretty slick. All the software is free, everything's free. This chip's about, I don't know, $3, $4. And so for roughly $10, you've got a real nice motor driver or whatever else. This will do Morse code, it'll do whatever you want. It's programmed in the basic language. It's very powerful. It's got maybe 300 or 400 commands to work with. There's also the Arduino, we'll get to it later. So the advantages of the microprocessor, you have very low parts count, very low cost because you're not buying parts, and driving around town looking for the parts. I've been doing this since I was like 12 years old, making things. Everything's expandable because you're doing it with, you're taking your imagination, converting it into software or computer commands, and proceeding from there. And sometimes there's some stumbling blocks, but you learn from it. Prototyping boards are available, so you don't have to do very much solder. You just plug the chip right into the board. These are very low power. In the case of the chip in the solar tracker, it'll run from 3AA batteries. It draws a few milliamps, that's not very much. What draws a lot of power would be LEDs and motors, so on and so forth. You can run 2-line or 4-line displays or dot matrix graphic displays. That's all quite possible and easy. Some variations would be the Arduino, which I think a lot of you have heard about, and Parallel X chip, and the Raspberry Pi. We had a little discussion on that.